Hey guys, Buildzoid here, and today we're going to be taking a look at some oscilloscope measurements for a GTX 570 DirectCU2. You might be wondering why we're doing that. And my response to you is like, because I want to know if the voltage regulation on this ancient card that had a VRM failure is any good, right? Like, also, this card has a prodlyzer, which is one of those like giant flat SMD capacitors which you don't see on any modern hardware anymore. And the reason you don't see them anymore is because those things are notorious for having a miserable endurance. As far as I know, they were never produced in endurance ratings higher than like 85 degrees Celsius in 2,000 hours. Um, and that's why we don't see them anymore. It's just like they were really, really unreliable. But back in the day, they were actually a really common feature of a lot of high-end GPUs, and even some other boards would have like a prodlyzer as part of their output filtering because in terms of actual like electrical performance, these things are supposed to be absolutely incredible. The whole idea behind the prodlyzer was like, oh, we can replace the city of multi-layer ceramics that normally goes behind a chip with this one big capacitor, and it performs, and like the voltage regulation is the same. This is great. And see, that would be great if it weren't for the fact that prodlyzers are notorious for dying constantly. So anyway, this card suffered a VRM failure. I bought it as like a broken card on eBay. I fixed it. I made a video about fixing it. And yeah, I was just kind of wondering, like, hey, how's the voltage regulation on this thing? Because it has a prodlyzer. It's evidently not had a particularly pleasant life. Um, so yeah, also we're gonna try to overclock it because just because the voltage, like the thing is, like, just because the voltage regulation is bad doesn't mean it won't overclock. It just means it'll overclock worse. Also, Fermi GPUs are actually kind of fun to overclock just in general because they actually scale with voltage. And it just occurred to me that I have the oscilloscope hooked up on channel 3 and all of the measurement stuff is on channel 1. I might give me a second. I'll reconnect it. Okay, so now we're on channel 1, and we can see that our average voltage is 900 millivolts. I actually don't really care about maximum voltage. Like, the overshoot looks really ugly, but from an actual, like, performance perspective, that it's not going to hurt our overclocking headroom, the minimum voltages. So, yeah, anyway, here we go. I don't really have a plan. I'm going to put this over here. Like, ultimately, like, being able to see the waveform is nice, but at the end of the day, I'm actually just going by the measurements from the scope. I'm not, like, judging things by eye, in my opinion, is not a good way of judging things. Anyway, I think we're just going to do, like, a stock run, and my preferred VRM or voltage regulation test is a Firestrike GT1, and already I'm not impressed. Like, what we're seeing, like, that. I'm almost wondering if I like connected the coax to the card wrong. Because yeah, those spikes did not look good. Actually, maybe we'll just run the GPUZ render test because this card's probably old enough that it won't have idle time. If you run GPUZ render test on some modern GPUs, oh wait, is the PCIe? Oh, that's kind of annoying. Wait, is that going to be a problem when I run the GTX 590? Ugh. Oh, I remember hearing about this being an issue. Also, yeah, the voltage regulation is atrocious. Yeah, that also... Wait, let's zoom in a bit. Yeah, that's still not looking good. Let's pull the trigger in. Because I do actually want to look at some of these spikes. Like, it's possible that maybe, like, if the probe isn't connected properly, like, you could have, like, a ringing issue where a fast edge going into the coax. Like, I do have a 50 ohm termination at the oscilloscope, so that shouldn't really be an issue. Well, no, if you screw up the connection, then you can have like a discontinuity in the impedance, like right at where you made the connection with the coax, like to the card. And so if the connection is crappy, you'll actually see like way more peak to peak than you're really supposed to be seeing, because yeah, it just causes weird issues. Anyway, what did I want to do? Oh, I wanted to add peak to peak. Where's my peak to peak? Because peak to peak is another one of those measurements where it's like, it's not actually that useful in terms of like, oh, 200 millivolts peak to peak, is this bad? And the answer is, I don't know. Actually, no, it's bad. It's bad. Okay, no, like reference AMD GPUs normally run at around 200 millivolts peak to peak at full load. Right now, we're running the GPU-Z render test. This is bad. But then again, this card did suffer a VRM failure, and also this really doesn't look like there's anything wrong with my connection. It does look like this card just does this. Yeah. I mean, I'm a bit, where's my pointer? Oh, no, what? No, come here. Wait, what? No, that's not the pointer. Nope. There's the pointer. This is kind of suspicious, but that might actually just be a thing that the card does. Yeah. Yeah, that might actually just be a thing that the card does. It's one of and the thing is, like, the waveforms you will see on GPUs, like, vary based on the architecture and mostly actually just the architecture. Like, certain architectures are incredibly noisy, especially everything modern NVIDIA is, like, super duper noisy. Some like older architectures are actually really quiet. But I think the thing is, like, I've measured like a OEM GTX 560 Ti, and that actually looked just fine on the oscilloscope. So I think this card probably, like, the output filtering is at least partially broken, which would make sense. Like, it uses a prodlyzer right behind the core. If that prodlyzer is like partially or almost completely dead, I would not be surprised. It does run Firestrike. I have successfully run Firestrike on this card, but yeah. Also, I've not run any other GTX 570s, so I don't know. Maybe the 560 Ti is just much better regulate, like much less transient heavy than a 570. But I kind of doubt it. They're both Fermi GPUs. I would assume that they would behave somewhat similarly. Also, I should pull up NV Inspector so that I can crank the fan speed, because if I don't do that, I'm like the coax is currently like held in place by a. Oh, that is very loud. Okay, not that. There. It's currently held in place by some blue tack, and the problem is if the PCB gets hot, then the blue tack is gonna stop sticking to the card properly, and that's gonna be a bit of an issue. Anyway, so let's just run GT1 and see what it looks like. I'm expecting it to look absolutely atrocious at this point, because like the GPU-Z render test was really, really bad. But it could also be that maybe the VRM has some weird power saving mode. So the voltage regulation actually looks not... Yeah, it really doesn't look much worse under load, does it? If anything, it might... Yeah, so I guess the VRM was in some kind of like power saving state where it doesn't like... where the voltage regulation is worse, because maybe the VRM is running like one phase, and so maintaining voltage regulation with just one phase is a lot more, potentially more difficult, depending on how the VRM is designed. Because yeah, that wasn't actually that bad. I mean, yeah, it was like 200 plus millivolts peak to peak, but I've seen NVIDIA cards hit 300 and 350 and higher, so that is interesting that, like, at idle, like at low load, it looks really terrible, but you run Firestrike on it and it actually looks okay-ish. Yeah, I'm surprised by that. Let's go. Maybe I should run something that runs at somewhat higher FPS. Maybe like 3D Mark 11. I'm not sure if I have 11 on this system. Also, no, 3D Mark 11 has too many different graphics tests. But yeah, this really doesn't look that bad. Which is surprising after seeing like the idle voltage regulation being so awful. right? Like at idle, we were getting basically the same results at full load. So yeah, that's quite interesting. Also, we could actually, yeah, we could show the power draw while it's running. This is on a 13900K, and so the power consumption of the system is on, like right now the system is pulling as much power as the 7800X3D does at full load. 13th gen true. Like, to be fair, the GTX 570 isn't helping. This thing is not like this. It's a Fermi card. It's not going to win any awards for efficiency anytime soon, or really even back when it first came out. Anyway, let's make it less efficient. Where are my overclocking tools? So, I'm not actually sure that it scales all the way to that. So we're just gonna apply the voltage. Wait, why can't I change the clocks? Oh, it's because we have, okay, yeah, you have GPU clock, shader clock, and here we control the shader clock. So, let's go for 900 megahertz on the core. And I'm just going to quickly check that the core voltage actually applied with GPU-Z. It shouldn't be an issue. It's a GTX 570, but yeah, it actually applied. So now we're at like 1.07 on the oscilloscope for average voltage, which there's going to be a little bit of V-droop. So that makes sense. That if I set 1.1 volts, we get 1.07. That's fair enough. I actually imagine under Firestrike, we're going to see even less voltage, maybe like 1.05. We should also see the voltage regulation get somewhat worse. Yeah, so now we're seeing like almost 300 millivolts peak to peak. Because the car, like the thing is, if you're running at a higher voltage, the current draw is much higher, and so you get bigger transients. Oh, so it can't run 900. Well, that's disappointing. Like 900 core is not that high for a Fermi card, right? Like, yeah, just 902, and it's already not working. Also, back in the day, NVIDIA cards didn't have power limits, which is kind of fun. Like, NVIDIA cards having a power limit is like a 600 series thing. Before that, it was just like the card pulled whatever it pulled. Yeah, so the voltage regulation gets even worse. So this honestly, like looking at this, I feel like this is something that like this could benefit from extra capacitors. I'm honestly kind of tempted to try desolder the prodlizer and like replace it with a bunch of multi-layer ceramics. The thing is, desoldering prodlizers is really not fun because they have like a plastic casing, and I've not managed to desolder one of them without having the plastic casing melt. So that's not, a particularly pleasant soldering experience. But yeah, so the voltage regulation on this thing is atrocious. As far as I can, yeah, I'm relatively certain if I go through my collection of Fermi cards, I will find at least one JF110. Not the actually, I'm pretty sure the OEM 560 Ti I have is a JF110 because it's like a weird, like a weird 560 Ti with 1.28 gigs of memory instead of the usual 1 gig of memory. Because it's like an OEM card, it has less shaders and more memory. Or I should say less CUDA cores and more memory. And I'm pretty sure it's a JF110. But, okay, it's a heavily disabled JF110, so, maybe not really a fair comparison. I'm actually going to go for a full run. And well, you know what? No, let's juice the memory a bit and see if that makes things even worse. Because the thing is you clock the memory up, it's gonna the memory is going to be less of a bottleneck on the GPU core. And so potentially the voltage regulation will get even worse as the core is able to pull, like, because if the core, like, how much power the core pulls is basically tied to how much data the core is processing. And so if you can't put enough data, like, if you can't get data to the core quickly enough, it'll actually pull less power. But it doesn't really seem to be getting any worse, which I didn't really expect it to. But yeah, we're hitting like 300 millivolts peak to peak. This I think would definitely benefit from, at the minimum, extra capacity. Like, so the reason I don't usually bother with like replacing capacitors, like I've seen other people do it where they'll like desolder the old capacitors and replace them. The reason I don't bother with that, at least with polymer capacitors, if you have liquid capacitors, then yeah, I can totally understand why you'd want to completely replace them, because those things can leak, and the liquid that's inside them is not particularly good for PCBs or people. But with solid polymer capacitors, like if the capacitor fails, like due to age, it just kind of behaves like it isn't there. So like removing it is completely unnecessary because it functionally isn't there anyway. Right? Like from an electrical perspective, it's not really there in the first place if it's like too old to function properly. But yeah, this thing's voltage regulation sucks. Um, I wonder if we can push the memory even higher. You know, I just realized that we did not run a full round of Fire Strike with the card at stock. Um, I have like very little 500 series. Like I don't have a ton of 500 series experience, or I don't really remember most of my overclocking of NVIDIA 500 series cards. Like I've messed with a 560 Ti. I've overclocked this 570 in the past without the oscilloscope hooked up. Um, I kind of wonder, like, if I could shave off, I could totally, yeah, I'm relatively certain I could easily shave off like 100 millivolts off the peak to peak. But the thing is, that's not necessarily going to do a whole lot, right? Because your peak to peak is the difference between your minimum voltage and your maximum voltage. Maximum voltage doesn't cause crashing, right? When the GPU crashes, that's because the minimum voltage is too low relative to the frequency it's trying to run at, or because the temperature is too high, which is why like liquid nitrogen is helpful for pushing chips further. But I'm wondering, the thing is, yeah, the thing is when you're adding capacitors, it's really easy to like deal with the overshoot, right? So like storing the extra, because basically the overshoot voltage you're getting is the excess energy stored in the inductors getting pushed into the capacitors. So if you have more capacitance, it doesn't even need to be particularly fancy capacitors with like super low ESR or anything. That excess energy will quite happily just get dumped into the capacitors, and it's not really, so it's not very difficult to reduce your like peak to peak without actually improving your minimum voltages, right? So like this right here, this is what is like, that's where you want to get improvements, and usually for that, like multi-layer ceramics work well. The issue with multi-layer ceramics is that they don't have a lot of capacitance, so you need a lot of them sometimes to get a significant improvement. And that's why, like, typically any GPU or motherboard is you're going to have like bulk capacitors, which will be polymers, right? Those are really slow, but they can store a lot of energy, so they're great for like suppressing overshoot. Also, if you're like they can help with undershoot as well. It's just that they're not particular. Depending on how fast the transient is, they're not necessarily going to be that helpful. And then you're going to have multi-layer ceramics of varying shapes and size. Like, well, not shapes. They're always rectangles, but you're going to have you're going to have like a variety of different sized multi-layer ceramics between the VRM and the GPU core, or the CPU socket, to basically deal with the really fast the really fast part of the transients. And yeah, so with this card, I'm kind of thinking like, yeah, if I just want to crush the peak to peak, you could literally throw like a couple thousand microfarads of polymers and that'll crush the peak to peak. But I don't necessarily think that would really change the minimum voltage very much, which would overall basically be not helpful in any, like that basically means it wouldn't really help the overclocking headroom on this card much at all. I wonder if we can just max the slider, which means I should be using a better utility, but I'm not even sure. Actually, I probably have Afterburner, but not really a priority. I mainly want to. So the thing is, now I'm like really tempted to try like a bunch of different capacitor configurations on this card, and it's like, man, this was supposed to be a quick test. Well, if nothing else, if I measure my GTX 590 and it's getting better peak to peak than this, I can feel good about my e-power job. That's assuming I run it at the same voltage, because obviously if you run the card at significantly less voltage, lower current draw, smaller transients, better voltage regulation. Oh, and now it crashed. Oh, I guess too much memory clock then? So I guess we don't get to max out the slider. Well, at least I don't have to feel bad about the slider not being long enough then. Man, I wanted to set 2250, but the precision required is beyond me. So I wonder if we can push the core clock any higher. And now I think I'm going to go for like a full run of Firestrike, and then we're going to do one at stock just for comparison. I haven't tweaked anything on this system. In fact, I don't even know what settings the CPU is running right now. I think it's stock. That looks stock. Wait, is it? No, it isn't. 6400 on the memory for some reason. Well, the CPU itself looks stock. I'm not sure why the memory's at 6400. I don't remember enabling XMP or anything. But anyway, let's hit it. Wait, did I just go custom again? Oops, wrong escape button. Firestrike, details there. Oh no, I have system info. Screw it. So the thing with disabling system info is like you can't, post your score online, because disabling system info actually boosts your scores very slightly, because system info does like a bunch of monitoring in the background, and obviously that monitoring takes away some of the resources that could be used towards running the benchmark. So it makes like a small performance difference to the score. And the other issue is like also it's like what 3D Mark uses to validate that there isn't like timekeeping issues, or that the hardware that you're running is at what what it actually is supposed to be. So yeah, but it doesn't matter if we're just doing a comparison locally, right? Like if I run the same card with and without system info twice, both overclocked and at stock, then yeah. Also, the artifacting makes me think that GT2 might crash, because GT2, so GT1 hammers the GPU core. GT2 actually seems to be hammering the GPU core pretty hard as well, but GT2 generally hits the memory harder. Also, I'm just going to quickly clear our data, and man, that is like our average voltage is like 1.09 volts, and our minimums are averaging 950 with an absolute minimum of 937. Man, that is awful. That's like 150 millivolts of just like undershoot on the core voltage. So that's great. And I think like if I could improve the minimums by like say 50 millivolts, so go from like 950 average to like a volt, the card might go like right now we're doing like low 900s. I think with the same voltage it might be doing like mid 900s. Yeah, like, so that's the thing is like, so cap mods, it's just like it's not gonna take a card that's like terrible and make it amazing. But it'll take a card like, and I think this is pretty average for, actually no, I'm not sure. Again, not a ton of NVIDIA 500 series experience, so I'm not actually sure if this like 900-ish is average for a 570. That's like GTX 480 clocks. I'm pretty sure this is slightly below average, but I might be able to get the card up into being average with just better voltage regulation, right? So instead of running like, what is it? Where's my GPU Z? Yeah, so instead of running 911 megahertz, we could maybe run like 930, 950 with better voltage regulation. But yeah, it's not going to be like, like it's not going to be a drastic change. But obviously, if you're going for like hardware bot rankings, every megahertz helps. Well, you have to keep in mind that certain GPU architectures have like fixed frequency steps. So like if you're on a Kepler card, you need at least 13 megahertz for it to actually make a difference to performance, because the cards do not have like a 1 megahertz increment for the core clock. But anyway, yeah, so that was 913 with like 1126 memory, or like, yeah, 911 on the core and then 1126 on the memory. And we're getting like 5,000 GPU points. So now we're just going to set the card back to stock, apply defaults. Did that actually apply? Yeah, so now so we're getting 5,025 points right now. We should be getting like 4,000 points at bone stock. Also, I wasn't paying attention to the power draw, but it was like over 300 watts. I imagine that right now we might be seeing like closer to 300. Like, it's still not going to be particularly amazing. But the score should be around 4,000 points, because I did actually run the card at stock before shooting this video. Oh, whoa. I made the power consumption so much worse. It's like 100 watts less. Oh, well, that's expected. When you bump the voltage by 10% and the core clock by like... We're going from, what, like 750 to 900? That's like 15%. So... yeah, that makes sense. I could actually just escape out of physics. There's not really much point running it if we just care about the GPU score. I do want to quickly rerun the high voltage just to see how much the power draw changes. So right now, like, we're basically pulling slightly under 300 watts, and this is full system power draw, right? Like, this is at the wall. It's with the inefficiency of the power supply and the inefficiency of the VRM on the actually, like, so there's like a whole bunch of power losses in the chain. This isn't just the GPU power draw. It also includes the CPU and the memory and the cooling and everything. But when we just overclock the GPU, obviously that increase in power consumption is from the GPU alone. Yeah, so like 4,128 points. And with the overclock, it was doing 5,000, what was it, 25, I think. I'm not even, like, I don't remember correctly. So that's like a 21% increase in performance. Man, old GPUs are just so much more rewarding to actually overclock, because there's headroom. Yeah, the thing is like, yeah, on modern GPUs, you don't have a functional, like, you don't really have a properly functional voltage slider on most modern GPUs. Especially on the NVIDIA side, the voltage slider is more like a placebo slider. But the thing is, on modern GPUs, if you actually had access to a voltage slider, it wouldn't actually help very much, because they're all very thermally limited. And yeah, now we're pulling like 340 watts, and that's without the core clock increase. Right, because the power consumption goes up both because of the core voltage, right, but also because of the frequency you're running at. So we're just going to bump it back up to 1,800. And now we should be seeing like 370-ish watts, if I remember correctly. Yeah, so that's like 100 watts of extra power consumption for a 20% performance increase. Overclocking was never power efficient. Like, we've actually, yeah, we're seeing like overall system power consumption is up like, I want to say like 33-ish%, right? Because previously we're a little under 300 and now we're well over 300. So that's going to be somewhere around 33%. So yeah, no, overclocking was never power efficient, but at least back in the day, you did get like noticeable performance improvements instead of modern GPUs where it's like, oh yeah, the power consumption doubled and the performance went up by 5% or 10%. 10% is if you're lucky. I I really yeah, okay. I'm definitely cap modding this card. I might even do I'm not going to do that on this video. I might do that. Maybe I'll do another video. I don't know. I've been yeah. Anyway, the power consumption just goes through the roof when you clock the card up and raise the voltage, which is not surprising. But yeah, anyway, so that's this random GTX 570 DirectCU2 that I got off eBay with a VRM failure, and evidently the output filtering on it has kind of... Actually, I'm not sure, because the thing is, like, it's hard, because how do I know that when the card was new, that the voltage regulation wasn't still this terrible? Oh, actually, I think I have a much healthier GTX 570 DirectCU2 that I could compare against, because this one had an outright VRM failure, and with like VRM failures, a lot of the time that'll actually send like high voltage to the output, and that can trash the capacitors. Before it necessarily, like if you're lucky, it'll like just trash the capacitors and actually leave the core alone. I think that happened to a GTX 980 Ti that I repaired, because that 980 Ti had just the worst voltage regulation I've ever seen on any GPU. And it clocked like absolute trash, and then I added a bunch of extra capacitors, and it still doesn't clock particularly great, but it clocks a lot better. And it sort of had me wondering if like maybe that VRM failure roasted like a good chunk of the card's output filter, because it's a bunch of like 2-volt polymer capacitors, right? So if the voltage applied to those capacitors was like slightly too high, like they would be internal, like that would damage them quite significantly. Um, though you would also think that would also probably harm the core quite significantly. Then again, people were running 980 Ti's on LN2 at like 1.8 volts. So it's not necessarily impossible that the core might actually be more resilient to overvoltage than the actual like output filtering capacitors, which is weird to think about, but not necessarily impossible. So yeah, anyway, hopefully you've found this video somewhat interesting. It's not particularly useful because, let's be honest, this is a GTX 570. It's like 12 years old, something like that, so not particularly relevant. But yeah, hopefully you found this interesting. So that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. Thanks for watching, and goodbye.